Sorry about that. So x is given, right? X equals 1, so we're asked to find the y value. So when x is 1, the y value is?
3.
That's it. And can anyone give us the ordered pair we read from?
1, 3.
That's it. Now, also we have this question, f of x equals 2. Can anyone tell us what does f of x equal 2 mean? What is given here in f of x equals 2?
It's when the y value equals 2.
Exactly. So this time I have to draw a horizontal line. Y equals 2. Does it hit the graph? It does. And it hits when x is 3. So x equals 3. And can anyone identify the ordered pair for us?
3, 2.
That's it. X is first, y is second. Perfect. Now moving on to these types of problems. Of course, they get more and more complicated. Let's look at a radical. Let's look at a rational. And if you want, we can look at these two radicals. That's fine too. Okay, so I'm going to start with 43. For 43, we have f of x equals 3x minus 1 over 7 minus 2x. How do I determine the domain of this function? It's okay if you're wrong, just anyone that I haven't heard before.
The denominator equal to 0.
So the denominator cannot equal 0. Very good. So then I move 7. So this is negative 2x not equal negative 7. When I move a term from one side to the other, all I need to do is just change its sign. And now I divide both sides by, anyone? Oops, sorry.
2.
Yeah, my keyboard is in the way.
Or negative 2, I'm sorry.
I know I hit this. Can you still see?
Yes.
So when we divide by negative 2, so this is 7/2. Perfect. So that cannot be. So can anyone now give us the domain for this? If this is not a good color, always tell me, please. Or any.
So it would be negative infinity to 7/2 with a bracket.
It would be terrible if I put a bracket out. I will include it.
Oh, okay. Then parentheses.
Yes, union.
And then a parentheses 7/2.
Yes. Great job. Thank you. Awesome. Thank you. Okay, now back. I'm going to share my screen. Anyone, please, if you have questions, please. Anything. Okay, so that's what a rational function. It's a ratio of two polynomials. Rational function. Okay, then.
This is R2, correct? My bad. R3.
No worries, no worries. I always go back. I like to go back and to see. I didn't write it here. You're right. I should have. So 43 on page 32. So we're on page 32.
Oh, I thought this was reviewing, but these problems are R.3.
Yes.
Okay.
Yeah. Good. Sorry about that. Good. So let's go back to a radical function like, I don't know, 45. Other questions here? Can I move on? So 45 g of x equals the square root of 4 plus 5x. Can anyone tell us how we start? How do we think on this one? I'm going to sip it with the water. How do we think about this?
The square root can't be a negative number.
So we're talking about domain. Indeed, the result of the square root is 0 or positive. That's true. But you're talking about range, if that's what you meant. We're asked to find the domain.
Oh, all real numbers?
There will be a situation that is not possible. Can I take the square root from -3?
Oh. Do we have to set what's under the parentheses that it can't equal 0 and then go from there?
I can take the square root from 0, is 0.
So it's going to be starting at the number that causes it to be the square root of 0, and then go from there.
Good, so excellent. How do I write that?
Hold on. Well, first I guess we'd have to find what makes.
I have to write something to
What?
show everyone what I'm writing and then solve it. Don't solve anything. Just tell me what to write. Anyone?
4x or 4 plus 5x like does not equal 0, and then work it out like we did the last one.
I can take the square root from 0.
4 plus
well, then
5x
-1.
Is it 4 plus 5x is greater than or equal to 0?
Yes. Thank you so much. The square root can be taken from positive numbers and 0. The square root from a negative number is not real. So this expression has to be positive or 0. So we solve this by moving 4 to the other side and dividing by 5. We know that. And we get -4/5. And now how do we write this domain? That's excellent. That's all I needed you to say. And then from here we solve. And now the domain.
That'll be bracket -4/5 to positive infinity.
Excellent. Well done, Manny. Thank you. That's it. Now on something more sophisticated, like for example this, we have to intersect, because this is a function that is made up of a sum of two functions. So this has to exist and this has to exist. So let's quickly address that as well. So this is 53, still on page 32. And I have f of x equals the square root of x plus 1 plus the square root of 6 minus 2x. So this is a sum of two functions. So what will I write? And both of them have square roots. Can anyone else than Mallory and Brendan say something? And Manny? Anyone else? Don, would you tell me what to write? Kim?
Do you have to do set each square root?
I'm not setting the square root equal to anything. So that's why we need to talk about the topics to make sure that it's clear. So obviously it's not clear. There is no discussion about the square root here. The discussion is about something else. Don, are you with us? Trey? Don, are you with us? Okay, Don is not with us. Trey, are you with us?
I'm with
yes.
you. I'm really confused on what to do, really. So I'm just writing down the notes.
But do you notice what we did here? The 4 plus 5x, when we wrote 4 plus 5x greater than or equal to 0. Do you understand why?
Not really.
Can anyone explain? Anyone? What we just did? Anyone else I haven't heard from?
Oh, sorry.
No. Jalen, you want to say something? And Brian and Sarah? Anyone?
So because you can't have a negative number under the square root, it has to be either greater than or equal to 0, which
Brilliant.
is why we had that function.
Brilliant.
So for the next one, it would be the same, but we would do it for each of the square roots.
I'm ready. Anyone? Great. Excellent. Well done. So what do I write, Rachel?
You would do x plus 1 plus 6 minus 2. X plus 1 equals 0.
Is that what we wrote?
Greater than or equal to 0. Sorry
Good.
about that.
No worries. And now? Anyone else?
It would be 6 minus 2x is greater than or equal to 0.
Brilliant. That's all I want you to say. Good. How do I solve this?
Subtract 1 from both sides.
Excellent. Here, obviously, I have negative 2x. I move 6. It becomes negative, and I divide by negative 2. What happens when I divide by negative 2?
Your sign gets changed.
Very good. Awesome. Great job. Okay, this is not done. In order for this function to exist, I have to find what it's called common domain. If these two do not exist at the same time, for some x values, this function does not exist.
So would it be where the two overlap?
Awesome. Brilliant. Thank you. That's awesome. Thank you very much. So, on the real line, with 0 in the middle, I need to plot this interval from -1 to infinity. Here's -1 with a bracket to infinity. This is this interval, -1 to infinity. Now with a different color, let's say blue, whatever, less than or equal to 3, right? So this is -infinity to 3. So 1, 2, 3, I don't need the units really. Can anyone give us the domain of function f, other than Brandon? Like Simone and Ari?
-1 to 3.
That's it. Thank you very much. Awesome. Okay, I think we have enough of this, so let's continue. Where is my button here? Okay.
Hey, can you go back real quick?
Yes?
Yeah, man, we need to write down that.
Yes.
Thank you.
Thank you.
Thank you. Good. I'm going to share my screen. Oops, I have to plug in my device. Hold on.
Jalen had a question about flipping the sign when there's a negative.
Right. So
Check the chat, man. Someone asked a question there.
say that again, Hersh.
Someone asked the sign question in the chat.
Okay.
Jalen.
Yes. Already Mallory warned me on that. Thank you so much, to both of you. So is 2 less than or equal to 10? Is 2 less than or equal to 10?
Yes.
Let's say we multiply by -2. This is obviously -4 and this is -20. Can I still keep this? Is -4 now still less than or equal to -20? No.
No.
Good. So that's the reason why we have to switch the symbol. And we do that every time we multiply or divide by a negative number. Because otherwise this will not be true anymore. Is that okay, everyone?
Yep.
Okay. Moving on. Let's take a look at this problem, 63. We are given a huge function here. What is the degree? Can anyone give us the degree?
4.
Good, indeed. Thank you. Is degree 4. Can anyone identify the domain for this function?
I'm gonna assume that's
25 to 100.
25.
Excellent. 25 to 100. Excellent. Can anyone give us the range of this function roughly?
0 to 550.
450. Completely agree. 450, 460. I completely agree. Very good. What 10-year age interval sees the greatest increase in the incidence of breast cancer? So we're asked to look at intervals of 10, from 0 to 10, from 10 to 20, from 20 to 30, etc., etc. What 10-year age interval? Because this is the age, and this is incidence. My computer is so far away because I have all my devices and papers here. So it says incidence of breast cancer per 100,000 women. Okay. So can anyone say, anyone else I haven't heard from, if you'd like, what is the 10-year age interval that sees the greatest increase in the incidence of breast cancer? And I will also ask how many per 100,000 women. Anyone?
Oh, I guess between 70 and 80.
Yes, it appears that this is it. Between 70 and 80, the highest increase. And it appears to be roughly that 450, maybe 460 per 100,000 women. Good. So we know how to read from a graph. And I think I don't have to say anything else about R.3. So now we can move on. Now in R.4, so needless to say, 60%, my lab math, at least 60% for Wednesday on R.3, please. And now we are going to look at R.4. We already discussed R.4, it's lines. So let me quickly review with you the important formulas and situations here. And let me start a new